Greetings, everyone. We're back, starting again with problem 7. Use figure 1, this figure, to approximate the z-score that corresponds to the 25th percentile. Now, that means that we need to find the z. We're not told what z to use. So we have to work backwards on this. 25th percentile means that 25% of the data are to the left of whatever this z-score is. So, excuse me there, I banged the microphone. We simply have to figure out, well, what will be 25% of the data here? Well, there are 400 of these rectangles, so we want 25% of 400, so that would be 100 rectangles. So we want to find the 100 leftmost rectangles. So therefore find the 100 leftmost rectangles. And there is probably some really fancy way of doing that. I'm going to simply count. So 1, 2, 3, 4, 5. There are 5. There are 9 at that point. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. There are 22 to there. 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46. There are 46 up to there. 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63. 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84. So at that point there are 84. I am going to leave benchmarks here, that way I'm less likely to lose my count almost to the end here. 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96. So 96 to there. So the last 4 have to be divided along here. And if I were really clever, I would say, well, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I would figure exactly, that would be 4 out of 13. So I would go an additional 4 out of 13 this way. Well, 4 out of 13 is an additional 0.3 that way. Well, so I would have that distance be about 0.3. That means that I need to figure out what this z would be. So I would come down 1, this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.67. So that would be 0.67. And it's negative because we're coming down. So, and I guess since this is 0.3 of a tenth, I really should have said that was 0.03. So that's a reasonable approximation of what the z-score. And again, it's getting at the idea that probability equals area. This is the area below this z-score is equal to the percentage of the data. Hence, it's equal to 25% of the data. So we're going to find that the z is approximately negative 0.67. Now, that's counting 100 boxes is about the limit of my patience. On an exam, I probably ask you to count quite a bit fewer than that. We often find this problem stated in terms of z-tables. So we're trying to find the z-score that correspond to the 64th percentile and the third quartile. So we have two jobs here. So what we do is we go to our z-table, and we're looking at the 64th percentile. Well, read down the percentiles, and we find that the 64th percentile will be between 63.6% and 65.5%. It'll be somewhere in there, but not exactly on both of them. So what we can do is we take the mean of both of these and get a reasonable approximation. So I'm going to copy this data onto this sheet here. So 64% is between 65.542% and 63.683%. That's rather sloppy. So that means that the z-score that we want is going to be between a z of 0.40 and 0.35. So we could simply say that our z is going to be 0.35 plus 0.40. This is very sloppy interpolation, just simply taking the mean because it looks to be about halfway between. So add those up, divide by 2. 0.35 plus 0.4 divided by 2. So the z is about 0.375. Now, we could do the same thing with the third quartile. We simply have to realize that the third quartile is the same thing as the 75th percentile. So we go back to the table, this time in green, and we're going to find the 75th percentile. Well, once again, what we're after is not exactly there. 75th percentile is below 75%, and it's above 74%. And once again, we're going to do the cheapo poor student's interpolation and simply take the mean because it looks like it lies about halfway between there. So we're between here and here, and it looks to be about halfway. So we can take the mean of 0.65 and 0.70. So z is going to be approximately the mean of 0.65 plus 0.70 divided by 2. 0.65 plus 0.7 divided by 2, and we get 0.675. If you're not satisfied with the crudeness of simply taking the mean, look up on Wikipedia, or there's undoubtedly a lecture, maybe a Khan Academy, linear interpolation, which is the old-timey way of doing it. The easier way is to find yourself simply a more accurate z-table. So let's see. This looks like it's missing something. So I'm going to pause the lecture here and go see what's going on.